Hello and welcome to another video. In this video we're going to be going over all the problems from Weekly Contest 403. And so let's get started. So in this first one, it's a pretty easy one. You have an array of floating point numbers averages, which is initially empty. And you're given an array nums of integers where n is even. And you want to report or repeat the following procedure n minus n over 2 times. Remove the smallest element and the largest element and add this number to the averages. Return the minimum element in averages. So they kind of show you what you do. Basically all you do is you just always take the biggest and smallest number out, and then you get the average of them and you put them into an average array. And then they ask you what's the smallest element in this averages array, which is over here. So we don't actually need to make an averages array. We can just use a 2-pointer. So let's say, for example, we have this example here. First, we can sort our numbers. So 1, 3, 4. Let's just keep it small. Let's say it's this. What we can do is we can just have a 2-pointer where 1 pointer is at the start, 1 pointer is at the end, and then we can just take the average and minimize that. So we can say, like, let's take 1 plus 9 over 2, 3 plus 8 over 2, 4 plus 7 over 2, and whichever one's the smallest, that's what we'll keep. That's basically what we're doing here. We just sort 2-pointer and then just take the average of the two numbers and return the smallest one. So pretty easy. I think these easy problems you should be able to do in like a minute, to be honest. They're almost all like super easy. Okay, second one. So you have a grid and you want to return the smallest area to cover the grid. This one's also pretty easy. Basically we need 4 variables. We need like the left border, the right border, and the top and the bottom of the rectangle. And the way to do this is every time we hit a point, so first we can initialize things to make them like as big as possible. So we can make the left infinity, we can make the right negative infinity, the top infinity, and the bottom negative infinity. Just so we make them like the opposite of what they want to be, right? Because the big rectangle, the left is going to be tiny, the right is going to be big, the top's going to be tiny, and the bottom's going to be big. So you basically just standard, just make them really the opposite of what you want to minimize them to or maximize them to. And then anytime you hit a point, so let's say you hit a point over here. So if we hit a point in here, that means that our left has to include this. So we can just say like our left, or sorry, not our left, our top value, like let's start with the top. If our top value is bigger than this of the rectangle, then we need to minimize it to include this value. And that's what we do here. And then also the same thing for the bottom. So if our bottom doesn't cover, basically you just check for does every side of the rectangle cover this value, and if it doesn't, extend out your rectangle to cover that value. So for example here, when we start here, our left will be 0, our right will be 0, our top will be 1, and our bottom will be 1. Then when we come over here, we're going to need to extend the top out 1. Right over here, and then the bottom will stay the same, the right will extend, and so on and so on. So I think it's easier to see in the code. Basically we just say if it's a 1, just extend out all the dimensions to make sure you cover that cell. And then once you have the so here I have x0 is the left, x1 is the right, y1 is the right, and y1 is the bottom, and y0 is the top. So y is like height, x is width, x0 is on the left, x1 is on the top or the right, and then y0 is on top, and then y1 is on the bottom. So pretty simple. You basically just literally maximize your points to fit, you maximize your dimensions to fit every point, and then you should return an area. Not much to do there. I think pretty easy one. Okay. The other way you could probably do it is you could see like what's the leftmost point in the grid, what's the rightmost point in the grid, what's the topmost point in the grid, what's the bottommost point in the grid, where you just, I mean that's kind of what we're doing here essentially, right? Like what are all those? So like the topmost point is at 0, the bottommost point is at 1, which means our area has to be from 0 to 1 height wise, and then left to right, the leftmost point's at 0 and the rightmost point's at 2, so we have to cover 0, 2. So that's basically what we're doing with these top, bottom, and all these things. We're just keeping track of leftmost point, rightmost point, topmost point, bottommost point, 4 values. Right. So this one I kind of made it a little unreadable. So I just did space optimize bottom of DP to practice a little bit. But you can basically do normal DP here. So this is basically you're given an integer array nums with length n, And this is a little bit confusing, but essentially what you can do is you can split your n into as many subarrays as you want. And every subarray, the way it works is you have a positive value, or actually not a positive value. You have your value times 1, and then your value times -1, and then your value times 1, -1, and so on and so on and so on. This is the format of every subarray. But if we have multiple subarrays, every time it starts with a positive value. So like if we have a subarray here, it'll be positive. If we have a new one, it'll be positive, 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 positive. But then once you continue the subarray, it'll be like positive, negative, positive, negative. And you can stop whatever you want, wherever you want, and you can make as many subarrays as you want. So let's take a look. So here they show you the way you want to split this into 1, -2, and 3, because then when you have 1, -2, and 3, is the first array, this first value will be multiplied by 1. The second value will be multiplied by -1, so this will become positive. Then this will be multiplied by 1, so this will be positive. And then the second array will start off as positive, so this whole sum is 10. So that's the best. In the second example, you want to split your arrays into like this, kind of obvious, because this will be positive, this will be negative times -1, so you'll get a positive, this will be positive, this will be negative times -1, you'll get a positive, then you have a 4. So this is basically like an easy DP take or not take problem, where at every single index, you just say like, first of all, you have to know like, is this current number going to be multiplied by a positive or negative, which we can just keep as a state in a DP. That's just like a Boolean true or false. And then we have a choice, right? So if our number is positive, then we have a choice. Actually, if our number is positive, it doesn't really matter what we do, right? So for example, if we have an array like this, and now we're saying we have a new number like 3, and we know this 3 is going to be positive if we put it in this array, or it's going to be positive if we keep it by itself. It doesn't really matter what we do here, right? No matter what you do, you can always just like put it in the current array, and then the next number will be either positive or negative. That's up to you, right? If you make a new array, it'll be negative. If you keep it in this array, it'll be positive. So when you have a positive number, no matter what you like, you actually, so when you have a positive number, sorry, I did that wrong. When you have a positive number, you have two choices. You can either put it in, you can either put the number in this current array. So like, let's say we have like just this first starting number. So we can put our number in here, and then the next number can go in here as well, which will be negative. Or you can put the next number in another array and it'll be positive again, right? So from positive, you can either have the next number be positive or negative. That's like your recursion state. But if your number is negative, so let's say we have something like this. If your number is negative, that means it can't be the start of a new array. It has to be like part of some existing array. So if your number is negative here, like if we, so let's say we put -2 or whatever, 2, and then this will be like times -1 here. So if this number is multiplied by -1, the next number has to be positive. So it's basically, if your current number is positive, the next one can be positive or negative. It's your choice. But if your number is negative, the next one has to be positive. So if we go back to this example 1, for example, if this number is positive, this number can be positive or negative. We can add it in here, and that will make it multiplied by -1. Or we can put it in a separate thing, and then it won't be multiplied by -1. So that's our transition state. And if our number is negative, so like this number, if we choose to put it in here, the next number, no matter what you do, will be positive. If you put in the third number here, that's positive. And if you put it here, that's also positive. Okay, so let's go over this bottom-up solution. So this is, I made this a little bit more confusing than I needed to. But this basically represents the next number, what it can be. So the first one is next number will be positive. And here, next number will be negative. I'm just going to write this down so I don't forget it. Okay. So basically, like I said, after the first number, the second one can either be positive or negative, right? Like in this case, let's just say we have this. And by I mean positive or negative, I mean multiplied by +1 or -1. So if we put a 1 in here, this first number will have to be multiplied by +1. But the second number can either be multiplied by +1. If we do this, this will be multiplied by +1. Or we could throw it in here, and this will be multiplied by -1, right? Because it's the second number, so we multiply and get this. So our transition state here is just in order to make the next number be positive, this is not the current number. In order to make the next number be positive, the current number has to be negative, so you just take the current number and make it negative. And then you add what used to be here, right? So this basically, in order for, we can write this down. So next number positive means current number negative, and previous number, yeah, so current number negative, I guess. And this is what that means, right? So this case is this number will be negative. So if this number is negative, then the next one will be positive. I did make it kind of confusing. I also made like a caching solution, which makes it a little bit easier. But basically, you can kind of play around with this. So, for the next number to be positive, the current number has to be negative, and then we're going to add current number is negative because the current number is negative, right? So this is next for like the next state, but now once we're on that state, now it's the current number. So once we get to the second number, this is the current number is negative, and this is for the current number is positive. So for this -2, the current number, if it's negative, then we take it and we multiply it by -1, and this is the current number is negative. Okay. And then the other case for it to be positive is the current number is positive, right? So we can just do something like this and then make a new array. And then we can make another array for the third number. So we can keep we can always keep numbers positive, but we can't always keep them negative. But this is the other case, basically. You keep the current number positive, and then you use the old positive number. So this is basically like positive, positive, positive. And then there's only one case for it to be negative. So the only way for the number to be negative is it has to be positive now. So in order for it to be positive now, basically this is the next number, this is the current number is positive, and then we just add that number. So for something to be negative in the future, this current number has to be positive. For something to be positive, it could either be negative now or it could be positive now. And you basically just run through this whole thing, and yeah. I also made a caching solution, I believe, some time ago, so you can try that as well. So it's a similar thing. I think there's a few different ways to write it, but basically you just keep track of the index, and is a number positive? If it's positive, do something. If it's negative, do something. Kind of easy stuff. I think you can actually have it, like, you can do it a few ways. So the thing I said is like one of a few ways to do it, but basically all you need to do is just keep track of, like, am I putting it in a new array, or am I keeping it in this current array, and where can I go from each state, right? So if the current number is negative, like I said, the next one will always be positive no matter what you do. And if it's positive, then the next one might be negative or positive. You can have two branches there. So yeah, I made this a little bit complicated with this bottom up, but this is how you do bottom up, and this will be of one space. I think this is like as good as it gets for this one. Okay, so the last one is the tricky one. It's honestly kind of hard to figure out where to start, so I'm going to explain this one. So this uses the previous problem of given a rectangle, or not given a rectangle, I guess, given a bunch of ones, like have a rectangle to cover them. But essentially, there's a bunch of cases here. So let's just take a look and find some of them. So as you can see in this case, we have 3 rectangles. So there we have one rectangle here, and one rectangle here. And this is one of the cases it can be. And now obviously rectangles can be like smaller or bigger, but they're going to look like this. And they're not always going to be, I don't think they're not always going to like cover the whole square, but they're going to look like this. There might be gaps, and I'll show that as well. So this is like the first one. So you always need to make 3 rectangles, and you need to make 3 rectangles with a minimum total area to cover everything, instead of 1 rectangle. So here we have an area of 2, 2, and 1, so we have an area of 5. This is another case where you have 1 rectangle on the top and then 2 rectangles on the bottom. Like I said, there can be spaces as well. So here we have an area of 5 as well. And there's more cases, so I guess I could show some of those. So I guess we could show all 6 cases really quick. There's only 6. And let's just first of all show a rectangle. So if we have this one rectangle, essentially there's 6 ways to split a rectangle up into smaller rectangles. So let me show those. Yeah, I'm probably just gonna actually show them all, like, yeah, I think keep them all. So let's say we have 1, and I'll just draw them all. 3, 4, and this is kind of hard. This is very hard, to be honest, to come up with. But I think once you see this, like try to code it yourself because it's still not super easy. So once you see this, maybe stop, pause, see if you can code it yourself. But essentially there's 6 ways to break a rectangle into 3 rectangles. So way number 1 is like this, where you have 2 rectangles on the top and 1 rectangle on the bottom. Now, there will be gaps, and I'll explain the gaps, or not always, but there can be gaps. I'm just saying this is like how to break it up if there are no gaps. So here, this would be no gaps. So this is one way. The other way is, or there's basically another way just like this, except the other way. So just like this way. Let's try to copy that. Okay, so this is number 2. So as you can see, 2 on the top, 1 on the bottom. Then you have 1 on the top, 2 on the bottom. You also have this case where you have 1, 2. Now, obviously, they're not always going to be like the same like size and whatever. These can vary, right? And all of them can vary in size. Like they're not necessarily equal rectangles or anything, but they just have it somewhat equal. Okay, so this is another way. 3. Then you have the reverse of that. 4. Just speed it up a bit. Okay. Now 5 and 6 are just 3 in a row. So either 3 like this, or the other way, like this. And those are the only ways you could split up a rectangle into 3, assuming you cover the whole area. But there might be gaps. So any one of these can be like, you can make a lot more versions with gaps. So like maybe this one will be like this or something, right? Like there might be a gap like this, because you only need to cover ones. So like, let's say there are no ones in this thing, it might look like this, or so on and so on. So if we go back, so yeah, there can be all these gaps basically, and the gaps might be as big as you want. But for example, for this case, these two will have, actually they won't necessarily have to have the same height either, because there's gaps, like, but it's going to have this shape, right? So like, for example, there might be a bunch of ones missing. It might look like something like this, right? It might look like something like this. Like, let's say there's only ones down here and here and here. It might look like all kinds of this, but this still boils down into this category. So let's go back to our examples and figure out what category they're in. So this is the category of 3 in a row, right? We have 1 here, 1 here, 1 here, which is the same as this, but now we have the gap, right? Because, so basically what you do is you try all 6 of these versions, and you can actually just brute force all of the rectangles. So let's say we try this rectangle here. We just, because the dimensions are pretty small. Then for each one of these, we say, can we shrink this to cover, we only need this rectangle to cover the one. So this is the area we're covering, but now can we shrink it? And we can, right? So this is basically like, given this grid of these dimensions, what's the biggest rectangle to cover that? And that's basically the previous problem, right? That's this guy over here. Just given this grid, what's the biggest rectangle? That's that problem there. So we're going to like reuse something like that. So basically what's going to happen here is these two will say this, and then this one shrinks to this. Okay, now let's go to the second example. So this example is 1 on the top, 2 on the bottom, which is this guy. And the rectangle we would have to try here is this. And then here, I think there's a few different ones, but let's say we split it like this. Then basically these two are going to shrink to just be this and this. And then we have 6 total. So that's kind of the idea here. And now basically it's like, there's 2 things you need to do. A, how do you do this efficiently? How do you actually split this up into rectangles? And B, how do you write a function that basically takes some dimensions and then gets the biggest rectangle to make? So this is going to be very similar to this guy, not that guy. I think you didn't need to cache here because you only need to do this once, but it's basically this. So this is basically this function to get that, and then you need to try all 6 of the things. So let's walk through this thing now. So basically we're given 6 dimensions, or not 6 dimensions, we're given the dimensions of the rectangle that we need to cover. And then we do kind of the same thing that we did in the other one, and we loop through all of these, and then we just get like what's the biggest rectangle we need to cover all of these, so it might shrink. So for example, in this case, if we're given a rectangle like this rectangle won't shrink, like if this is the dimensions we're given, but let's say we're given dimensions like this, then this will shrink to this, right? So that's kind of the idea. So this function is basically just given 4 dimensions, what's the smallest rectangle you need to cover those dimensions. Now we need to cover all of those cases. And so this is where you do this. So basically, you just have a nested for loop where the x and the y is where you're going to be breaking. So the x and the y for all of these cases, this is where you're going to be making this break between your things. So like this is a break here, 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 right? All these things. So let's take a look at maybe like a couple of these cases and see how it works. So 1 top, 2 bottom is this guy. And so there will be a y, which is like where, like what point do these break? And then there's also an x, which is what point do these break? And so you can see that here it is. So x is the columns and y is the rows. So y is vertical and x is horizontal. And so if you actually take a look, then here, so this first state is 0 to columns to 0 to y, which means x, it's going to cover the whole grid, and then y, it's only going to go to a certain point. So if x, it covers the whole grid, and then y, it goes to a certain point, that means it's this top box here. So this first thing is this box right here. This 1 over here is corresponds to this in the code. And then the second one is y all the way down. So that means y all the way down is down here, and then it's 0 to x, and then the third one is x to columns. So the second one goes 0 to x and y down, and then this is this one. So it's basically like 2, 3 in the code. And that's how you do all of these. You just basically have a nested loop, and you just say like at what point in x am I breaking, and at what point in y am I breaking. And for all these conditions, then you just figure it out, like where you need to be doing. So 2 on the top means there's a separator between the 2 on the top, right? So there's going to be an x break here and a y break here. So here it is here, right? So it goes all the way down to y, and then it goes to x, and then the second one goes from x to columns. So these are the 2 on the top, and then this is the 1 on the bottom. It spans the whole of x, and it goes y. It spans the whole of x, and it goes y all the way down to rows, which is that one. So that will take care of these 4 for you. You just like change these a little. Now these 2 are pretty easy. You just need 2 breakpoints. So here is like an x1 breakpoint and an x2 breakpoint, which is this. So you just literally say like, okay, let me try every single breakpoint possible, and then let me get those 3 rectangles. So you just say 0 to the first breakpoint, the second breakpoint to the third one, and then the third one to the end, right? So first, the start to the first breakpoint, in between the 2 breakpoints, and the second one to the end. That's those. And then the same thing for up and down. You just try every single point possible because these dimensions are small enough. So you just say like, okay, my first one will be, this will be a y1, this will be y2, and let me just try everything possible. And then yeah, you can use this function because you are going to get like repeated calls, so you can have a cache. And then this will basically, so the idea is basically just break down this big rectangle into some combination of 3 of different sizes, like, right, they can vary. They're going to vary all the way from, you know, whatever, like every single rectangle possible. And then once you do get this actual rectangle, you just figure out like for example, for this rectangle, let's say there's only ones down here. Then this dp function will shrink this rectangle to the minimum it needs to be to cover those. So it's kind of like get every combination of rectangles possible, then for each rectangle, figure out where all the ones are, and give me the smallest possible rectangle to cover those ones. So that's kind of the idea. Like, let's say there's ones over here in this one, maybe like over here or something, then this one will shrink to, obviously this is an illustration, but it'll be a little bit different with like a matrix, but it kind of looks like this, right? If there's ones over here, it'll shrink to this. Let's say there's ones like this here, it'll shrink to this. So hopefully the image makes it clear of like what's happening. So there can be gaps, but initially there are no gaps, and then you just make gaps, you know, if needed, because there are just I just don't need to cover any ones. So this kind of takes care of every single possibility, but knowing that there's the 6 combinations of rectangles, it's pretty tricky. But then I think breaking it down like this makes it pretty good. You just figure out, okay, there's 6 combinations. How do I get those efficiently? And then solving the sub problem of given dimensions and a bunch of ones, what's the smallest rectangle I can make to cover all the ones in these dimensions? That's just the previous problem. So we can run this guy and get a wrong answer, apparently. I wonder if I changed something. I had a submit pass, so curious why. Let me just copy. Maybe I changed something. I don't know. Let's see. Okay, yeah, I don't know what I changed, but yeah. So basically, maybe I just like deleted something. But that's kind of the idea. So hopefully that makes sense, and I would recommend you to code it up now that you can recognize what's going on. So break it down to these parts, given dimensions, what's the smallest rectangle I can make, and how do I break down my rectangles into these 6 categories. So let's go through this time and space. So for this one, basically, so here, this is x times y, so it's like n times m, and then in the DP itself is n times m as well. So it's like n times m times n times m, and then this is n times n, and this is m times m. So I think it's like, if you have to combine everything, I don't think it's a square, so it's technically going to be like n squared m squared plus n squared, or it's going to be like n cubed m or something, mn cubed plus, actually, is this going to be mn cubed? Yes. I think so, yeah, because here we're just looping like through rows twice, and here we're looping through columns twice. So I think it's going to be something like this, nm cubed. So the DP is nm, and then this is n squared and m squared, and this is n by m. So I think it's something like this. Okay, and then space. So did we actually use any space? I don't think so, just 4 variables. Yes, I think just O1, I think. Oh no, sorry, we have the DP function, so obviously we have space. So yeah, so this DP function is gonna have space, so it's gonna be 4 dimensions. So it's gonna be like n squared m squared, I think. Yeah. Okay. Okay, so let's see. Curious how this thing does. Let's find out. Okay, so that is good. So that is exactly what we said. And this guy, okay, nice. So that is exactly what we got. Okay, cool. And this guy is, so this is the O of 1 space solution, and time is O of n. This is a pretty easy one. Yeah. And I'm assuming this one will be correct. Yep. Okay. Yeah, so this thing is pretty good, to be honest. I did realize that like for longer problems, like my segment tree one, I think it does have like a limit of stuff it can do, but it's pretty accurate. I'm curious how it's gonna do for the graph ones. I think the graph ones are trickier, like backtracking, but we'll see. I think for these it's like pretty straightforward. I think just GPTing it will give you the right thing too. So I guess we didn't talk about it, but this is just nm time, and then O1 space, I think. Let's see. Yeah, oh, it even gave you the row column. Interesting. Is it because I don't know how I came up with that. Interesting. I wonder if it has to do with like variables or something. I don't know. Okay, so yeah, this is nm and O1. And then the last one is n log n. Yeah, another fun fact that people said in my videos is, so sorting functions aren't really O of 1. Like in Python, I think it's like it's not O of 1. In Java, it's not O of 1. But people just say it's O of 1, so kind of interesting. So I think it's like log n or some other thing, depending on what you use. Let's see. Yeah, it just says it's O1. Yeah, so I guess just keep saying it's O1. I don't know. Okay, but yeah, it's going to be all for this one. Hopefully it was helpful. If it was, please like the video and subscribe to the channel. If you have any questions, just write in the comments. And yeah, I'll post the Python code and I'll see you in the next one. Thanks for watching.